Hello, in this video, we are going to walk through Challenge Lab, creating a VPC networking environment for the Café. Let's click on Start Lab to start the lab environment and wait several minutes until the AWS icon becomes green. And then click on the link to open the management console in a new tab. Switch back, click on AWS Details, and click on Access the Multiple Choice Questions to open the multiple choice questions in the new tab. Switch back. So in this lab, we are actually going to create two subnets, right, within the lab VPC. One public subnet and one private subnet. So we're also going to create an internet gateway and also a NAT gateway. So we will observe all those network components and how they interact with each other together to build your VPC, right? So, and also we will explore the security components such as the network group and network ACLs. So let's start by creating the public subnet. So let's go to the management console, type VPC in the search box and click on VPC. Also, you need to ensure that, we are in the US East 1 region. And we click on subnet from the left-hand side and click on Create Subnet. Select the lab VPC. So we are going to put public subnet as the subnet name. In terms of the AZ, choose US East 1A. So this is the IP range for the VPC, right? So that the subnet CIDR block range is a subset of the VPC CIDR block range. So let's use 10.0.0.0/24. So with that, we click on Create Submit. And next, we need to create the Internet Gateway. So click on Internet Gateway from the left-hand side. So a default Internet Gateway is there, but that's attached to the default VPC. So we need to create a new one for the lab VPC. So click on Create Internet Gateway. We can put the name, say, hey, demo IGW, and click on Create Internet Gateway. So, and we click on Action and Attach to VPC, right? So we need to attach the Internet Gateway to the lab VPC and click on Attach. So last thing, we need to ensure that the public gateway, the public subnet route external traffic to the Internet Gateway. So this is actually illustrated by click on your VPCs and select the lab VPC. We can check the resource map, right? As you can see, the public subnet is associated with this default route table, and we need to establish the connection between the route table and Internet Gateway for outbound traffic, right? So we do that by clicking on the route table link So in the route, as you can see right now, we only have this one default local route. So click on Add Rules, click on Add Route, and we select 000/0, indicating it's outbound traffic. The target, select Internet Gateway, and select demo IGW that we just created, and click on Save Change. So with that, if we go back to the VPC resource map again, we now see that this public subnet is associated with the internet gateway for outbound traffic through the route table, right? So next we need to create the bastion host. Bastion host needs to be created within the public subnet, and we can SSH into the bastion host, and from there to connect to other EC2 instances in private subnets. So let's open EC2 console. So let's go to the management console, search EC2, and click on Launch Instance. For the instance name, we use bastion host, and we use Amazon Linux 2023 image. For the instance type, we choose G2.micro. For the key pair, select the VOK key. And for the network, click on Edit, select the lab VPC, and make sure the public subnet is selected. We need to enable the public IP address so that we can SSH to that instance. For the security group, we need to create a new security group called bastion host SG. And for type, SSH. And for port 22, source needs to be my IP. Therefore, only I can access to the bastion host, not the other IP addresses. That will increase the security of your bastion host. So with that, we click on Launch Instance to launch the bastion host. And wait until the bastion host becomes ready. So yeah, once the instance state becomes running, let's switch back to the lab instruction. So we under the AWS details window, click on download PPK. Because I'm using a Windows machine, so I'm going to use PuTTY as my SSH client. Therefore, I need to download the PPK file. And if you're connecting using Mac OS or Linux, you need to download the PM file. So, okay, I'll click on download PPK and save the labuser.ppk file locally. So if you haven't done that yet, this is the link you need to click on to download and install PuTTY. Click on here. This will actually download a putty.exe file that you can run and install your PuTTY locally. I already have downloaded and installed locally. So I double click on the link, and in the host name field, I need to paste the public IP address. So let's go here, go to the EC2 instance, select the bastion host, copy the public IP address, and in the PuTTY window, I paste it. And also on the left-hand side, on the SSH, expand auth, click on credential. For the private key file, click on browse and select the downloaded the lab user.ppk file. And click on open. And click on accept. So logging as I use ec2-user, hit enter. Now this indicates that I've successfully logged into my bastion host using PuTTY. So we can close this window. And next step, we need to create a private subnet. So let's switch to the VPC console. And here we click on subnet again. And click on create subnet. Select the lab VPC. For the subnet name, we call it private subnet. Select the same AZ, which is US East 1A. For the subnet CIDR block, we are going to use another one that is not overlapped with the public subnet. So we choose 10.0.1.0/24 and click on create subnet. So next we need to create a NAT gateway. So click on create NAT gateway. Even though the name is optional, we're still going to create one called lab NAT gateway. So first of all, NAT gateway needs to be resided within a public subnet. Okay, remember? And we're going to use the one we just created, which is within the lab VPC, right? So this one. And the second, NAT gateway needs to have an elastic IP address, right? So it cannot be, so you need to allocate an elastic IP address and associate with NAT gateway. So click on allocate, let's select that. So remember, NAT gateway needs to be first created within a public subnet, and second, have an elastic IP address associated with it. So click on NAT gateway. This will take several minutes to complete. So next, we need to create the route table to be associated with the private subnet, so that for any outbound traffic within the private subnet, it needs to be goes through the NAT gateway, right? So if we look at the VPC, let's go to the lab VPC, look at the resource map, right? So right now, both the private and public subnet route traffic to the internet gateway. So we need to fix that to have a new separated route table to be associated only with the private subnet, and for outbound traffic, associated with the NAT gateway, right? So that's something we want to do. So we need to create a new route table. So we click on route tables and click on create route table. Let's use the name private route table and select the lab VPC, right? And click on create route table. And for that route table, we first need to associate it with the private subnet. So we click on subnet association. Right now, it's empty, right? So we need to edit subnet association. We select the private subnet, save associations. Right. So second, we need to add a new route rule here. So click on edit routes. So this is the default local route. So we need to click on add route for any outbound traffic. So the target, instead of internet gateway, which is the case for public subnet, here it's actually routing to the NAT gateway. So that's a difference between the private and public subnets, right? So now select the newly created NAT gateway and click on Save Changes. So let's double check the route map. So click on VPC, look at the resource map. So this is the new traffic map, right? So for public subnets, routed to the internet gateway. For private subnets and outbound traffic, route to the NAT gateway. So now this is what we want, right? So use resource map to validate, to check your VPC setup, right? So make sure that the resource map reflects exactly what you want to achieve. So let's create some private EC2 instances in the private subnets. So let's go to the EC2 console, click on launch instances. So before we do that, let's hit back. We need to create a new key pair named voc2. So let's do that. So let's click on key pairs under the network and security. So click on create key pair. So we need to use the word voc2. And again, like I'm using putty, so I will generate .ppk file. Click on create key pair. So the voc2.ppk is automatically generated for me. So I saved it locally. So next, let's create the private instance. I click on instances and click on launch instances. For name, we use private subnet, private instance. Use the default Amazon Linux 2023 t2.micro. So for key pair, we choose voc2 instead of the voc key, which is used by the bastion host, right? So for network, we click on edit, select the lab VPC, and the subnet needs to be the private subnet. So we disabled the auto-assign public IP address because we're not supposed to get a public IP address for instances within the private subnet. We are going to create a firewall. So we will call this security group as private instance SG. Once again, we will allow SSH port 20. In this case, the source type should be custom, right? Because we only want to allow the instance of bastion host to be able to access that, so that for the source type, we either specify a very specific CIDR block range, which reflects the IP address of the bastion host, or we can use the security group that's associated with the bastion host as the source. So we use the bastion host SG. So this indicates any instance that is associated with this security group can access the private instance, right? So this is actually a more secure way of configure your security group. So with that, we click on Launch Instance. And we refresh the page, we will see that the private instance also gets created successfully. So let's move on to install another tool called Pagent. So Pagent is a tool that works hand in hand with PuTTY to allow you use a key pair that is stored on your local to access the private instance without uploading the key pair to the bastion host, right? So it's actually a more secure way of connecting to the private instance through bastion host. So let's first click on the download page link. So scroll down and we have the link for the pagent.exe. So click on link to download that file. So once downloaded, click on it. The program will be executed, and once it's being executed, if you look at your Windows system tray and click on the arrow, you will see a new icon being created, right? So this is Pagent, right? Which is a computer monitor with a head. So right click on this icon and you will see the menu, say view keys, add keys. So let's first click on view keys. Right now it's empty, right? So we need to add the two keys. Click on add key. First, add the VOK2 key. Second, click on add key again. Select the lab user key, right? So that the two keys are imported into Pagent, and click on close. Now let's open PuTTY. And let's connect to the bastion host again. Let's go back to the management console. Check the bastion host and copy the public IP address again. Go back to PuTTY, paste the host IP address, And on the left-hand side, click on SSH, expand it, click on off, select allow agent forwarding. Right, so this will allow agent to manage your key. And click on credential. And for the private key, we use the lab user. And click on open. Logging as EC2 user. Again, like we successfully logged into the Bastion host as EC2 user. Now let's log into the private instance, which is in the private subnet from the Bastion host. So we need to first get the private IP address of that private instance. Go back to the management console, uncheck the Bastion host, check the private instance, right? The private IP address is 10.0.1.241. So let's copy it, go back to party, and use command ssh ec2 user at, and paste the private IP address. Hit enter. Say yes. So this indicates that we have successfully logged into the private instance through the Bastion host. And then let's check if we can access outbound from the private instance. So for example, let's ping something. Yeah, so we can get a result. We can try something else. For example, .com. Right, so at least we get some response back. So this indicates that, yeah, the private instance was able to access the outbound through the net, net, right? The net gateway. So last, we are going to practice the network ACL. So let's go back to the management console, go to the VPC console, right? So let's examine the network ACLs first. So for the lab VPC, we have one network ACL, and we check the inbound rule, right? So it's basically allow all inbound traffic, and outbound rule allow all outbound traffic. So basically, there's no restrictions for this network ACL. So let's create another one and named it as Lab Network ACL associated with Lab VPC, and click on Create Network ACL. And if we unselect the previous one and select this newly created network ACL, if you look at the inbound rule, basically it's deny everything. And look at the outbound rule, it's also denying everything, right? So we need to add some additional rules. So to allow all traffics going into and out of the private subnet, we need first edit the inbound rules. Let's say add a new rule. You can use like 200 or type all traffic, right? So, and it's allow. And click on save change. Similar for the outbound, click on outbound, add new rule 200, all traffic, allow, and save changes. So, and also we need to associate this network ACL with the private subnet by click on the subnet associations and click on edit subnet associations and associate with the private subnet only and click on save changes. So let's create a test instance in the public subnet. Go to the EC2 console, click on launch instance, click on, the name is test instances, keep the default Amazon machine image, instance type t2.micro. Let's still use the voc key pair, click on edit for the network setting, selecting the lab VPC, make sure the public subnet is selected. Also enable public IP. Create another security group. Let's call it test SG and configure the following for the type. Instead of SSH, let's say all ICMP. So this is basically allow ping command and source anywhere. That's good. So with that, we click on launch instance and wait several minutes until the instance becomes available. Once the test instance is up and running, we switch back to the party window. Remember, here we are in the private instance, right? So let's first check the IP address of the test instance. So I copy the private IP address, which is 10.0.0.161. So here in the party window, let's ping that test server. And the ping command was successful, indicating that the network ACL does not block that traffic. So we leave this ping utility up and running, and let's add some restrictions to the network ACL. So let's go to select the network ACL, go to the inbound rule. Let's edit inbound rule. Let's add a new rule. Let's 100 to make the rule number smaller than the 200 rule. For all IPv4 traffic, the source, we paste the private IP address of the test server. Don't forget to specify the range, which is 32, and click on save. Sorry. Let's go back to the inbound rule. So instead of allow, we need to mark as denied, right? So can save. So we got this message say that there was an error updating inbound rule because As the lab user, I'm only allowed to add new rule but not to update. So if you ever face this similar issue, what you can do is to basically create a new rule which has a lower number to override that incorrect rule. So let's go here to do it again. Click on inbound rules and click on edit inbound rules. Right, so let's add a new rule. Instead of 100, this time I use like 50. The same type, or ICMP v4. Right, so the same source range. Instead of allow, we use deny. Can save changes. Double check verified inbound rule. So basically, we have two contradicting rules. Same condition, one is deny, one is allow. Because the deny rule has lower rule number, it will be used for evaluation. So with that, so let's go back to the party window. Control C to terminate it. And let's rerun the same command again. And now you see that we don't get any response back, indicating that the traffic has been denied. So with that, let's take a look at the multiple choice questions. Question 1, what's the purpose of the Internet Gateway in the public subnet? So you can create a public IP address for instances within a public subnet, regardless you have Internet Gateway or not. So that's not the purpose. The purpose of Internet Gateway is to allow instances in the public subnets with a public IP address to communicate with the internet, right? So that's the correct answer. Select on submit. Question number 2. What allows the instance in the private subnet to connect to the internet? So it's a NAT gateway. 3. Can the instance in the private subnet be accessed directly from the internet? The answer should, of course, is no, right? Because it does not have a public IP address exposed externally. 4. Why do you use two different key pairs to access private instance and the bashing host? Of course, it's for increased the security. So in case the bashing host key gets compromised, we still like can ensure the security and safety of the private instance, right? So can the bashing host use ping and get a reply from the instance in the private subnet? Yes or no? The answer is no. Why? Because if we take a look at the bashing host, look at the security group, right? So it only allows port 22 be opened, right? And if you look at the private instance and take a security group, again, only allow port 22, right? So we can SSH into private instance because it's through port 22, but not ping command, which requires IMCP protocol and a different port to be opened. Right, so I can, the answer is no. Which security group allowed private EC2 instance to receive the return traffic when it pings the test instance? So don't be confused. Here, we are connecting from the private instance to the test instance. Therefore, in order for this connection to work, the triggering part, the private EC2 instance, should have the outbound rule to allow that outbound traffic. Right? So on the private side, that's outbound. And for the test instance, on the test side, it's inbound. In other words, the outbound traffic needs to be allowed on the private instance, and the inbound traffic needs to be allowed on the test instance. So this is the answer. Select submit. So with that, we conclude this lab. So let us submit the work by click on submit. Click on yes. And wait several seconds until the grade becomes available. And then click on grades. Don't forget to make a screenshot to capture your total score and attach to your assignment. With that, we can terminate the lab environment by first click on End Lab and click on Yes, and then go to the Management Console and log out from your console session. So this is the walkthrough video for this lab. I will see you next.